So we're back, still looking at measures of variation. Remember, variation is measuring how spread out your data is. So in this problem, we have a sample of 12 students. Heart rates in beats per minute, BPM is beats per minute, are listed below. So we have a sample of 12 students and we have their heart rates in beats per minute. There should be 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So beats per minute. Usually it's like around 70 or something. Really athletic people often have it in the 60s. In any case, first of all, we want to find the mean heart rate. Find the mean heart rate. That's called X bar, right? X bar. It's going to be the sum of all the X's divided by the sample size, N. So you're going to add up all those numbers, right? 70 plus 65 plus 58 plus 70 plus 62 plus 74 plus 71 plus 64 plus 72 plus 75 plus 67 plus 68. I got 816. I'm going to divide that by 12, right? Sample size is 12. So X bar divided by X bar is 816 divided by 12, that's 68. So the average heart rate here is 68 for this group of 12 students. Maybe got a lot of athletes in there, lowering the heart rate average a little bit. All right, so second thing we want to do, we want to ask you to determine the variance. Remember, the variance is the average square distance between all the data values and the mean. Determine the variance. And we call that S squared, lowercase s squared. And remember, the units are going to be square, beats per minute squared, right? Beats per minute squared is kind of an awkward unit, but in any case, remember the formula, right? The variance, S squared, is going to be the sum of all the X minus X bar squareds divided by N minus 1, the sample size minus 1. So what I recommend doing, I recommend making a little table here. Let's get a table going. Yeah, can we get a table going where you make an X column? After you have an X column, you're going to have, what, 12 values going down. You can have X minus X bar. And you can do X minus X bar squared after that. What color am I going to use for X minus X bars? I'll use orange for the squares. X minus X bar squared. And then what we're going to do, we're going to add those up down at the bottom here in the box. You're going to add up a little summation symbol. You can get this thing to scroll a little bit. Summation symbol, right? All right, so we got to put all our values in the X column. I got to have to scroll back and forth. So let's see. Go in red. I got 70, 65, 58, 70, 62. Runs out of space. 74 is going to be the next value. 71 is going to be the next value. 64 is going to be the next value. And we got 72. And then we got 75. And then we got 67. I don't have enough space here. And we got 70. And we got 68. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, looks like I got an extra 70 in here. I don't need that extra 70. Yep, I got an extra 70 in here somewhere. This guy right here. 68. Kind of hard when you don't have a screen that you can see everything on. All right, let's see. Make sure I got all my numbers now. 70, 65, 58, 70, 62, 74, 71, 64, 72, 75, 67, and 68. Okay, I got all my numbers. So now what we're going to do, we're going to take each of our red numbers in the X column and subtract the mean. Subtract the mean. So here we go. This is going to be in the yellow column. So 70 minus 68 is 2. 65 minus 68 is minus 3. 58 minus 68 is minus 10. 70 minus 68 is 2. 62 minus 68 is minus 6. 74 minus 68 is 6. 71 minus 68 is 3. 64 minus 68 is negative 4. Scroll a little bit. 72 minus 68 is 4. 75 minus 68 is 7. Okay, let's scroll up a little bit. 67 minus 68 is minus 1. And 68 minus 68, is that the last number? Yeah, 68 minus 68 is going to be 0. All right, so those are all the x's minus the mean. Now we got to square those numbers. We're going to put that in orange, right? Where's the orange button? There's the orange button. Okay, we're going to do 2 squared is 4. 3 squared is 9. Negative 3 squared is the same thing as positive 3 squared, right? Negative 3 times negative 3 is positive 9. Negative 10 squared is 100. 2 squared is 4. 6 squared, or negative 6 squared, is 36. 6 squared is 36. 3 squared is 9. Negative 4 squared, or 4 squared, is 16. 4 squared is 16. 7 squared is 49. Negative 1 squared, or 1 squared, is going to be 1. And 0 squared is going to be 0. So what we have to do now, we have to do the sum. We have to do the sum of those. Where's the purple? Right there. Now I'm going to do a little bit of scrolling here. Okay, I got to add all these up. I'm going to put a purple, come on, purple box. This is where I'm going to do my sum. So what happens when you add those up? 4 plus 9 plus 100 plus 4 plus 36 plus 36 plus 9 plus 16 plus 16 plus 49 plus 1 is equal to 280. So that's the sum of all those. So let me scroll back up. So I'm working on my variance here, my formula. I got s squared. That sum we just found is 280. So we're going to write the number 280 on top. And on bottom, we're going to do n minus 1. Remember, n was 12 because there are 12 data values here, 12 minus 1. So s squared is going to be, in fact, 280 divided by 11, which if you do that, it's going to be 25.4545 repeating. If you want to round that off to one more decimal place than the regular data values, you would say it's 25.5 approximately, right? So that's my variance. And the units here are going to be beats per minute squared, beats per minute squared. So square beats per minute, I'll say. Yeah, strange type of unit, square beats per minute. What does that even mean? I don't know. Okay, so let's ask a question about this now. Number 3. What does the variance measure? Variance measure. So if you were to say how spread out the students' heartbeats are, that would be fine. That's a perfectly good answer. If you want to be really precise, though, just use the definition of variance. What is the definition of variance? The average square distance in student heartbeats and the mean heartbeat. Yeah, it's a mouthful, right? The average square distance between student heartbeats and the mean heartbeat. So it's telling you how spread out. So 25.5. So let's say we want to get that in ordinary beats per minute. We're going to look for what's called the standard deviation. So step 4, let's find the standard deviation. Determine the standard deviation. Which we often call simply S, right? So S is going to be the square root of, oh, let me put this in a different color. Let's put it in red. S is going to be the square root of the variance. Remember what the variance was? It was 25.5. So I'm going to take S is the square root of 25.5, and we're going to approximate that. So what happens when you take the square root of that? You get like 5.0 something. I'm going to say it's about 5.05. Or if you want to say 5.1 roughly, you could. I've rounded it to 5.05. The second decimal place. You could go to another decimal place. The more decimal places you go, the more accurate you are. But it doesn't really matter. You could also say this is about 5.1. That'd be okay as well. It doesn't matter to me. I don't care. Yeah. So that is called the standard deviation. It's the square root of the variance. This is in beats per minute, right? The units here are beats per minute. Okay, so that's how you do it. That's how you find the variance in the standard deviation, which measure how spread out your data is. So 5.05, it's not a really big number, so that means the data is not too spread out. If it were a really small number, like 1 or something, it would mean it would all be bunched together. If it would be really big, like 10, it would be like way spread out. So let's look at your numbers. 70, 65, 58, 70, 62. That means they're not super spread out, right? So on average, if you take a typical number, the average number here is only 5 units away from the mean on average, which is 68. Right, the mean is 68. So the average number here, the average data value is only 5 units away from 68. All right, so I'm going to end there. That does it for variation.